Hey everybody, it's me, Chris Kubik. This is, I guess, the first real lecture for Art 173. And I want to talk about speakers here. This is going to be in two parts. We're going to talk about resistance today. Some of these videos that I'm going to make are going to be more technical and some more abstract. I'm going to tend to try to make the technical ones be sort of standing alone and then the ideas in another video. And we'll just see how it goes. As I said, this is all kind of experimental. So, when we listen to sounds, there's a speaker in here. It's hidden, of course, but you can kind of see it at the bottom there. And, how the sound sounds is affected by the size of the speaker, it's affected by the location of the speaker, and it's affected by the things that sort of surround the speaker. We also have these we can get a raw driver like this that would usually go inside of a box to make it resonate more clearly. And here's another one that's got, this one's actually got a tweeter inside of a paper cone. Speakers, I think, are pretty neat. They function, they translate electrical pulses into airwaves. And you can see basically it's an electromagnetic relationship. You have a big magnet, there's an audio signal that comes around this, they call it a former. There'll be a lot of wire windings, and you can see it if you open up any one of these speakers. It's maybe not totally obvious on any of these speakers. It's usually pretty well hidden, but a speaker will always have a magnet. You can see the magnet kind of clearly in this one, and you can kind of see the paper that's got the wire winding around it on this little guy that I got for like 10 cents, I think, from Parts Express. So before I go any farther, I just want to say this is my favorite website and they're not sponsoring me or anything. I wish they would. But I usually buy a lot of my parts from here, and I'll just wait till they're super cheap. They've got like these deals. What's this? $13. I don't know how much it's going to be, but drivers can get really expensive. These are really nice ones. Reference series. There's other ones on this website that'll be like, like I said, I think this one, these were like $1 a piece or something like that. But this speaker, this driver, since it's so small, is not going to give me very much low end. This one, although it is pretty small, is engineered in such a way that it gives decent low end if it's in a bigger enclosure. And then this guy here is actually in an enclosure, mostly. So that really helps for the low end response. And you can see there's a tweeter on top and a woofer here on the bottom. So speakers work by, like I was saying, they work by pushing electrical current many times around in the vicinity of a magnet. And that relationship between the electrical current and the magnet causes a cone suspension to move air. And that makes sound waves, which eventually get into your eardrum. If you want to explore this a bit more, there's a link on the course website here on how to make a homemade speaker. And it's really pretty easy. We used to do it. We've done it sometimes in class. Essentially what you need is a little bit of copper wire and some sort of a cone material, which can be a paper plate, and you need a lot of patience and a little bit of time, so it's a little bit long to do in class, I think. But you just take this copper wire, wind it around, say, a paper tube or something, and put it in proximity to a powerful magnet and push some current through it. So this is why I'm starting with speakers, is because speakers work using but they are essentially the simplest, nicest, sort of not dangerous electrical circuits that I know of. And so we can take something like this. It's a few wires. I'm going to have the red and the black here. I'm going to connect them to some banana clips. I'm going to connect this to a battery. So this battery is going to give me 9 volts, and we can measure that using a multimeter. So I'll just put this here, and we'll measure the output of that battery, and we'll just hope that everything's working the way I expect it to. And as we see, we get 9 volts. So there's 9 volts out of that battery. Now, I can use that 9 volts to drive my speaker. And I'll show you what happens. I can give it a nice square wave, right? So I'm going to go ahead and I'll use this one here. And we'll just connect the red to the red and the black to the black. And you'll see when I close the circuit, it moves that, and this one's a little bit messed up, you can see, but it moves that. Oh, that's really messed up. This one's super broken. So that's not gonna make great sound because that gasket you can see is broken. We can do it with this smaller guy too. So we'll just take the positive to the positive and the negative to the negative. And maybe I'll just close the ground and use the positive. It seems like that would be logical or something. This one you can see doesn't move nearly as much, but you can hear it doing its thing. So this is like super high frequency, this here. This is pretty brittle, doesn't move very much, doesn't have a nice gasket. That's why they were so cheap. But I think it's going to be fun for something. And so that's giving this, what I'm doing is I'm introducing into my room, right, a nice square wave. And I'm taking the power, and this one's broken too. All these are broken. And it's because I haven't been keeping them very safe. And probably they're here because I broke them at some point and I forgot. That's how we make the drivers move, right? As we introduce electrical current. And I'm just introducing this like raw, unfiltered 9-volt battery. But when we hook up these speakers to a amplifier like this one, this is a small amplifier. I got it again from Parts Express. I think it's probably like 12 or 20 watts of power. And watts is how we measure the amount of amplification to a signal that an amplifier can give us. So we're going to take in some electrical current from my phone, and we're going to move that electrical current using this wire, right? And these wires there'll be like a hot tip, so that'll be the red, and then the ground will be down here. And this one's actually stereo, so it's got the capability of having 2 circuits. So there'll be like a hot and a ground, or 2 hots and a ground in here. So a hot and a hot and a ground. And then we can connect that into this device, this amplifier. Usually there'll be some kind of an input, and will come out the red and the black. And so this will be a circuit between this red will go to the red of my speaker. And in this case, this is not a speaker like these. This is called a transducer. They're pretty neat. Let's take a look at it, or take a listen to it. Take a look and a listen to it. So I'm going to connect my phone up here, and you can see If I push play now, I should hear something coming out of the phone. And then I'm gonna let's just start this back at the beginning. I like this song a lot. No Name. Where's that there? So now I'm gonna connect this wire in here to get that sound coming out from somewhere other than these inbuilt speakers. So we'll connect this wire in here. We get no sound. I'm gonna turn this on, and you can see this one's a little bit funky. I need to make sure these batteries are pushed in. There we go. So now it's in there. Oh, no, it's not. There it is. Come on, stinker. Okay, so I got this turned up. I'm pushing play, and now we're getting nothing. No, we are getting something now. See, this is essentially the inside of a speaker. But if you could feel this part right here, it's vibrating, and I'll show you if I connect that vibrating part to this table. It turns this surface into that paper cone of the speaker. I love these. I think these are really neat. If I take it off, you'll hear almost nothing. Right, so this is the electromagnetic part of the speaker. This is vibrating, this little membrane here. And we can attach it to anything we want to create an actual speaker. Pretty neat, huh? Okay, so let's, and I can show you how I used those in artwork some years ago. Let's see, that I made with the artist Dan Walsh. And so this was a piece called Flesh and Blood. There was a couple different versions of it. I think there are a few other ones that aren't listed here too. Where what I did was I have this really enormous sound effects library, and I searched for the term flesh plus blood. So it returned any instances of sounds that involve flesh and blood from that library. And most of them are pretty violent because, you know, Hollywood. And then I just connected. This particular version, I think, was for a smaller gallery. There was another version at the Yerba Buena that had, I think, 6 or 8 channels, with each one having a different little one of these guys. And it got pretty violent on this glass. You can see maybe from this video. I'll just let you watch that on your own time. So I think these are really neat, these little guys. But I think all speakers are neat, and as I definitely have at various times enjoyed speaker building. And one question that comes up a lot is with speakers is, do we need to have does thicker speaker cable help? Is this better than this? People will argue about it a lot on the internet. I'm gonna let you tell me. I don't know. I can't hear a difference really between this or even a super, $10,000, they sell them, these really wide cables. I can't hear any difference, but you can tell me in the comments or in class, what your experience with that is. I'd be totally intrigued. Now, one last thing I want to talk about with speakers is impedance. And to get really to the points of today's real focus is this thing called resistance that I haven't talked about. But I want to mention every one of these speaker drivers is a resistor. And you can see on this one it's written what the resistance that it offers is. And you can see there it says 8 ohms. Power max 30 watts. So you don't want to give the watts is what comes out of the amplifier. That's the amount of amplification to the electrical signal that this amplifier generates. It converts the power of these 8 AA batteries into a heightened electrical signal. The electrical signal coming out of this headphone jack is small. When it leaves this amplifier, that electrical current is bigger, and it makes it possible for it to drive a bigger a bigger speaker driver. Now we can measure, and most of the time if an amplifier doesn't get resistance, it'll blow up. It's not exciting. You can search for amplifier blows up here. We'll say amplifier blows up. And we'll look at the images. And, well, I guess there's one that's kind of exciting. There's one that's a little bit exciting. But for the most part, it just looks like this. And if you're lucky, it won't actually destroy your amplifier, although I have destroyed many an amplifier in my times, inadvertently. So if this amplifier doesn't get enough resistance in this circuit, the circuit, remember, is going from this red to that red and back into this black. There's a circuit, there's a flow of electrons happening here. If this resistor doesn't resist enough for some reason, maybe it's broken, maybe there's a crossed wire, then this amplifier can, as a consequence, just go like da-da-da-da-da-da-da and just blow up. It will get too hot, the signal's too great, it can't handle it. So that amount of resistance is actually called ohms, and it's created by basically this. Remember when I was saying we can make a speaker by wrapping a bunch of copper wire? The number of turns of copper wire is what creates the resistance with the magnet that's inside of the speaker. And we can measure that resistance using, again, our trusty multimeter. So if I can find these things, we can set it to ohms, and I can go red, black, and we see 7.2. Now, this is listed as providing 8 ohms of resistance, but 7.2 is close enough. And one of the things I like about speaker building and working with speakers as a sort of beginning electronics work is the stuff is big, the allowances are pretty good, 8 ohms, 7.2, it's close enough for these purposes. Really what's most important is that your amplifier have some resistance. It can probably be 2 ohms and be fine with most amps like this. Some amps are very specific, and as you get more and more expensive in your parts, those allowances get tighter and tighter as the systems become more sophisticated. One last thing I want to show you is just what happens when you take two of these 8 ohm resistors and connect them together. So we can extend this circuit a little bit. We can connect, we'll have still our red, and we'll connect this one to this one. So we can connect this looping circuit here. So we've got boom, boom, and we could connect any number of these together, and many artists have worked. So you can see here, all of these are connected in this Abgehängt work by Christina Kubisch. And she's done just a lot with loudspeakers, and we can take a look at, is it the only one in there? Let's see. No, not light and sound rooms. She's done an awful lot with loudspeakers, but I guess they're not in here. Where each one of these can be connected, and we can see it better maybe on this Steve Rodin. Where's he? Sorry, guys. I have a link on today's syllabus on understanding ohms and impedances. There we go. So there's a, nope, that's not it. There we go. That's it. So Steve wrote in, there's also a link to his work. You can see this is like one channel of audio here. You could see you could have a bunch of speakers with one amplifier like this one by connecting them together like this, by sending the audio signal to all of them sort of simultaneously from one place. And the thing to know about that is that it means that this resistance is going to change. And there's a formula for this, which is really pretty straightforward. So if I connect this and I connect this, those were 8 before, right? Roughly 7 and change, somewhere in there. Now, when I connect them together, look at that. The resistance is much bigger. It's doubled. So that makes sense. If I connect them in parallel, so if I connect the red and the black simultaneously to both of them, then the resistance cuts in half. And we can create, we can use that math to make connections to multiple speakers. And I'm also somebody who's used that, come to think of it, in a work like this, where there's a whole bunch of speaker drivers, and these are actually these little speaker drivers here. I think this was left over from that project, where I think there's 32 of these connected together, and it's actually an 8-channel audio piece. So left and right, these are 2 channels. To make an 8-channel piece, I'd need 4 stereo sound sources, right? This is one stereo sound source, so it's going to have 2 channels. The 2 channels come in, the 2 channels go out. I would have this 4 stereo sound sources and 4 amplifiers, if that makes sense. And then it could go out to all those speakers. We could also have, there's so many different ways to configure these things. There's a bunch of links on today's syllabus of people that work with sounds and speakers and whatnot. I'm going to come back in a minute and talk to you a little bit about resistance and ideas, and a little bit about speakers, a little bit more about speakers and sound as well. So I hope that wasn't too long, and I will